Hi, good day, and welcome to my first video on trigonometry for the additional mathematics syllabus. Alright, I just want to explain the slight difference between the maths trigonometry and the additional mathematics trigonometry. In maths, usually when you're solving in a trigonometry equation with sine, tan, and cosine, when you are solving for the angle, you usually get one answer. However, in additional mathematics, when you solve a trigonometry equation, you usually get two answers. So today I'm going to show you how to get these answers and how it's slightly different from, not slightly, it's way different from normal maths. All right, so the first thing you want to do in your text, in your notebooks, draw this entire diagram. The S, T, and C obviously stand for sine, tan, and cosine. So you can pause the video, draw it, and then unpause it, and we'll start discussing it. Okay, so let me explain this diagram. It has 4 quadrants. You usually read it anti-clockwise. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. In the first quadrant, everybody is positive. Sine is positive, tan is positive, and cosine is positive. In quadrant 2, sine is positive, but the other two guys are negative. In the third quadrant, tan is positive, and the other two guys are negative. In the fourth quadrant, cosine is positive, and the other two guys are negative. Now, whenever an answer ends up in the first quadrant, you get something called the basic angle. The basic angle is the first answer you get using your calculator. If your answer ends up in the second quadrant, you have to use this answer. You take 180 and minus the basic angle. Don't worry, I'll explain what the basic angle is. If your answer ends up in the third quadrant, you have to use this formula, 180 plus the basic angle. And if your answer ends up in the fourth quadrant, you have to apply this formula, 360 minus the basic angle. All right, so let's try our first question. Here we have 4 sine theta is equal to 3. And of course, the aim of the question is just to solve for theta, which means we need theta on one side and everyone else on the other side. So let's try to do that. Between here and here, there's a secret multiply. So what we're going to do, we're going to take the multiply and throw it across, and it becomes a divide. All right. Now, whenever you're doing these types of questions, to utilize this chart, you have to ask yourself whether it's a positive question or a negative question. You figure out whether it's a positive question or a negative question when it's time to throw across the sine, tan, or cosine. That's the only time you can determine whether it's positive or whether it is negative, at the point of throwing across the sine, tan, or cosine. Right? So 3 divided by 4 is obviously 0.75. I prefer decimals. Right? Now it's time to solve for theta, which means we have to grab the sine and throw it across. Now you notice it's time to throw across the sine. At this point, you make the decision whether it's a positive question or a negative question. When I'm throwing across the sine, what does it meet? It meets 0.75. Is this 0.75 positive or negative? 0.75 is positive. So this is a positive type of question. So that's really important. So when we throw across the sine, it's going to be sine inverse 0.75. So let's sine inverse 0.75. Make sure your calculator is on degrees mode. Second function, sine 0.75. And you will get 48.59 degrees. Now, if this was a normal maths question, that's the normal CXC maths syllabus, that would be the end of this particular question. But in AdMaths, we are supposed to get two answers. So let's figure out how to use this chart for this question. Remember, I told you when we are throwing across the sign, we have to make the decision whether it's positive or negative. And it was a positive type of question. So go to the chart now and ask yourself, where is sign positive? Everybody's positive in this region, so sign is positive in this region. Is sign positive here? No, sign is negative. Is sign positive here? No, sign is negative. Sign is positive in this quadrant. So the first answer is this. The first answer is my basic angle. To get my second answer, I call this theta 1, and I'll call the other answer theta 2. I have to apply this formula because sine is positive in this region, and whenever something falls in this region, we have to apply this equation. So we're going to take 180 and minus the 48.59. When we work this out, 180 minus 48.59, we get 131.41. So this here is my first answer, and this here is my second answer. Easy enough? Well, this question basically had no tricks. When it's a positive type of question, it's pretty easy. But let's do another potentially positive one. Let's see. Let's try a tan. So this will be question 2. All right. Let's see here. Let's say we have 5 minus 2 tan theta is equal to minus 1. Well, let's call this 4 here. All right. Now, here's the thing about this question. At first glance, if I usually ask my students, hey, is this a positive question or is this a negative question? They immediately looked to this side and across from the equal side, and they see, -1. So they say immediately, hey, this is a negative question. So they've already made up their mind that tan is negative here and tan is negative here in the fourth and the second region, because in the third and first region, tan is positive. But they basically jumped the gun. You cannot decide whether it's positive or negative unless it's time to throw across the sine, tan, or cosine. So let's go about this question and solve for theta. What would we do? Who would we throw across first? We would throw across positive 5 to get negative 5. That's the first person we have to throw across. So we end up with -4. Tan theta is equal to -6. Next in line to throw across is the -4, which is a secret multiply. Throw across the multiply, we will get a divide. When we divide this, we get tan theta is equal to positive 1.5. All right? So now it's time to throw across the tan. But at the point of throwing across the tan is going to meet a positive number. So this is actually a positive question, not a negative question. Only at the point of throwing across the sine, tan, or cosine, then we can make a decision. So where is tan positive? Well, everybody's positive in this region. So we're going with the first region. And tan is also positive in the third region. So my first answer, my basic angle is tan inverse 1.5. So we throw across the tan, second function tan, second function tan 1.5. My first answer is 56.31 if I round it off properly to 2 decimal places. This is my first answer. For my second answer, I have to take my basic angle, and since we're going to the third region, we're going to take this answer and add it to 180. So I'm going to add it to 180, and we will get 236.31 degrees. These are my two answers. Right, next question. Both question 1 and question 2 dealt with positive types of numbers. When we are throwing across the sine, tan, or cosine, we were getting positive numbers. Let's do one where we get a negative. The negative is a little bit difficult to deal with. It has some rules in it that just simply don't make sense. You just have to accept it and remember the procedure. All right, let's try one. Where's my black ink, Lord? Okay. Let's say we have cosine theta. 3 cosine theta is equal to minus 1. All right, so this one is pretty simple to transpose. The first person we have to throw across is the 3. The 3 is a multiply. Throw it across, and we will get a divide. Now, obviously, this is minus 0.3333333, right? I'm just going to put it like that, 0.33, and it's reoccurring, right? Now, here's the thing. Now it's time to throw across the cosine. So when we throw across the cosine, we see, hey, it's going to bounce up a negative number. Here's the thing about whenever it goes across the meet a negative. When it goes across the meet a negative, to get the basic angle, we have to ignore the negative, okay? But we're only going to ignore it temporarily. Remember, this procedure is only when it goes across and it meets a negative number. So, temporarily, let's find the cos inverse of 0.33. Great. Notice we're ignoring the negative sign temporarily. So let's find the cos inverse. Second function, cos inverse of positive 0.3333. And we will get theta is 70.53, roughly around that. But remember, when it's a negative, we are ignoring the negative sign. I know that makes no sense. Just remember, when it's negative, ignore the negative at the point of throwing across the sine, tan, or cosine. This here is not your answer, but we're going to use this to get our two answers, okay? So remember, it was really a negative question because at the point of throwing across it was negative. Ask yourself now, where is cosine negative? Cosine is negative in the third region and it's negative in the second region. So we have to apply these two formulas for this. So our first answer will be 180 minus the 70.53. 180 minus the 70.53. So my first answer is 109.47. And my second answer, we have to use this formula. So it will be 180 plus the 70.53, which will be 250.53, right? Remember, he is not one of the answers. We are just using him to get the answers, okay? So that's the problem a negative sign causes. So these are the official two answers. All right, let's try another one. All right, this topic usually gives, this part of trigs usually gives so much problems in class you won't believe, right? Okay. All right, so that's why I'm taking my time here. So when you guys come to class, we can move at a really fast pace and in a smooth manner. Oh Lord, 1 second, guys, slipped out my hand. Wait. Let's try a harder one. Let's try minus 5 plus 2 tan, open brackets, theta minus, let's call it 45 degrees. Oh, wrote it too big. Well, I could probably put this equal to minus 1 here, right? There's a chuck it in there. All right, first of all, do not even think you can multiply every one in the brackets by tan theta. That is considered blasphemy in trigonometry land. I know in algebra, if I have x and I have 2 plus b, it's perfectly okay to say 2 by x is 2x and x by b is just xb. But when it's sine, tan, or cosine, right, and there's a brackets in front, please do not think that you could say this is tan x plus tan b, right? They will throw you in trigonometry jail in Trigsland for that. It is not allowed, all right? All right, so let's go about this question. I don't know whether it's a positive question or a negative question as yet. So the first thing I'm going to do is draw across the minus 5 to get the positive 5. So we'll end up with positive 2 tan open brackets theta minus 45 degrees is equal, well, when we draw across minus 5, we will get positive 5. So minus 1 plus 5 is 4. I believe you could do that in your head. That's pretty simple. So who's the throw across now? The 2. The 2 is a multiply. You will get a divide. So we end up with tan theta minus 45 degrees is equal to 2. Now, who is next to throw across? Remember, this whole thing is in front of the tan and it belongs to the tan. So that means we have no choice but to throw across the tan. At this point in time, we make a decision. It is a positive question, not a negative question. Up here, it looks deceiving to the eye, and you think it's a negative question. But at the point of throwing, right? So when we're throwing across the tan, we realize that this is a positive question. Now, here's the thing. As soon as we throw across that tan, we immediately have to get two answers. Then I will show you how to deal with this theta minus 45 degrees. But keep in mind, whether it's sine, tan, or cosine, when you are throwing across the sine, tan, or cosine, you immediately have to pause the question and get your two answers before you move any further. So when we throw across the tan, right, we're going to get tan inverse of positive 2, right? So let's see how this goes. Second function tan 2 is 63. When we throw across this tan, we'll get tan inverse of that, which is 63.43 degrees. Now, this is a positive question. Where is tan positive? Tan is positive here, and tan is positive here. So, my first answer is the basic answer, but this answer is equal to theta minus 45. And my second answer will be the basic angle plus the 180. So it's 180 plus 63.43, and you will get 243.43. But the question is not finished. We paused the question and we got our two answers, but these two answers are both equal to theta minus 45. The question asked us to find theta. The question doesn't care about theta minus 45. So in both instances, as soon as I get a good marker, we throw across the negative 45 for both of them. Of course, in both instances, when you throw across the negative 45, you're going to get positive 45. So we have to add positive 45 here and add positive 45 here to give us our final two answers as, that's now 63.43 plus 45 will give me 108.43, and my second answer will be 243.43 plus 45 will give me 288.43 degrees. All right, so I basically showed you an example of each scenario that you could bounce up in a basic solve for theta tricks question. These questions are really basic. I personally would not bring something so easy in an exam, right? But it builds a good foundation for the rest of trigonometry, which is going to be really long, guys. So expect a lot of videos on trigonometry coming in the future. Alright guys, take care, have a good day.